Hey guys, this is Mrs. Tran-Bloom and I am continuing Unit 2.1. So now we are picking up where we left off. You guys did your vocabulary earlier today. So now we are going to practice. The first graph is a V graph. Usually we call it an absolute value graph. Now I just want to give you a heads up. Can you guys see on the endpoints when we don't have any closed dots or anything like that? That means it goes on forever, okay? Now, in the case when you see ends with the dots, such as a closed dot, which we talked about being inclusive, and if it has an open dot, meaning not inclusive, then that means the ends do not go forever. So when you see that the endpoints don't have anything, always assume that the endpoints go on forever. So let's fill out the chart on the right side. It says X-Intercepts. In this case, we have two of them. One of it is at 3, 0. And remember, X-Intercept is when y goes to 0. So make sure you write y is 0. So that is usually a case of x and then comma 0. Then we have the negative of that, which is -3, 0. Next we have, we want to find the y-intercept. So y-intercept is when x is 0. So it's right here in the bottom. In this case, we want to write x0 first and then comma the y value, which is -3. Now, what happens if you just write -3? Then that's not correct. So make sure we write when x is 0, so 0, comma, and then y value. The domain is talking about all values of x, okay? So it's going to go this way because remember there's an arrow here. So it's going to go left forever and it's going to go right indefinitely. So this domain is all reals. Now I want to introduce you guys to also interval notation. All reals in interval notation mean that x is over here in -infinity town, right? So we want to start at -infinity and then somewhere, because it keeps going up and up and up and right forever. So this somewhere over here is a positive infinity. So it keeps going from -infinity to positive infinity. Now in interval notation, we always want to write the smaller x value first and then comma the larger x value. The range is talking about all values of y. Okay, I'm erasing the chart so I can start writing some more on it. Now y in this case, because it goes upward, okay, so what we want to do is we want to locate the smallest y, which happens to be -3, and then because it goes up and out, we know it keeps going up forever. So we can write this old school, y is bigger than or equal to -3. Now we also want to practice interval notation. As you can see, it's including -3. So in mathematics, if it's including, it's inclusive, we use this bracket. And then we write, okay, -3 all the way to infinity because we don't know when y is stopping. It keeps going up forever. We do have one vertex. The vertex is at the bottom here, which is, again, we can write the vertex as a point, which is 0 for x and -3 for y. Now, number of turning points. Remember the definition of turning points is when it changes from increasing and decreasing. So it is usually at the vertex. So we have one turning point. We do have a minimum, so we'll circle the minimum. And the minimum value right now is a -3. So minimum is -3 at x equals to 0. Now we can sometimes, in this class, we can write it as a point as well. So we'll take either. We'll take is -3 at x equals to 0, or we can take it as a point 0, -3. End behavior. This is brand new to us. I want you to pay attention very carefully. End behavior meaning that, hey, as x is getting really like going towards the left side, which is going towards -infinity. Remember, -infinity is this way, okay? What is the behavior of y? Well, this one goes up and up and up and up forever, right? So y goes up forever. So that means y is approaching positive infinity. Similarly to the right, as x is going to the right, okay, indefinitely, so approaching positive infinity. What is this guy right here doing? This guy right here keeps going up. Well, up means going positive infinity. Okay, and now end behavior is brand new to you, so make sure you ask more questions if it's confusing, okay? increasing interval. Okay, so now we want to find where the vertex or the turning point or the max and min is, and define and find that x value. So well, we knew this x value right here is 0. Remember we talked about decreasing. Decreasing is when you can slide down, wee, right? Wee. Okay, so that's decreasing. But where does it start? Well, x is over here. Remember, this is an arrow, so we don't know where it started. But we do know we can start at -infinity, 0, and that's the decreasing interval. Now, increasing interval, it's when you have to do a little bit of hiking. Okay, oh my gosh, this is so tough, right? Huffing and puffing, hiking up this mountain. So that's increasing because the y value is going up every time. Every step that you take to the right, y keeps increasing. That's why it's called increasing. Okay, so increasing, well, we start the same 0. Okay, so remember the vertex, usually the max or min or the turning point is when it starts the increasing interval or when it ends. It increases from 0, and because x keeps going and going to the right forever, it ends never at positive infinity. So increasing is from 0 to infinity, and then decreasing, it's where you could slide down from -infinity to 0, just like that. And again, increase and decreasing is super difficult, as well as end behavior. Now let's talk about if this is a function or not. Remember function, we talked about there's only one, sorry, I need to erase because I'm making so much marks here. 2 things, right? Every time we make an x, there's only one y. So whatever x I'm making, as you can see, it only touches one y. Now, this also passes your vertical line test. So this is a function, okay? Is it a one-to-one? Well, one-to-one is a little bit different, right? One-to-one, not only it has to be a function, but every y that you make, you can only have one x. Well, that didn't pass. Here's -4, that's one x, and here's +4. Wah, wah, wah. This is not a one-to-one. It did not pass your horizontal line test because it intersected twice. Now, this last part, if you don't have this written in your notes, just write it out. F of 2 is. Now, f of 2, we did this in Unit 1 already. So when we want to find f of 2, we go to the 2 for x, okay? And we want to see where it crosses or touches or intersects the graph. So in this case, it intersects at -1. Now let's continue with this next graph. I just want to remind you guys, a few of you guys picked up the notes packet from us in school. This changed slightly, so can you do me a favor and sketch this out in your notes packet again? So when you sketch this out, find this main point right here. This is the inflection point, so that's -2, +3. The reason I changed this was because the original graph didn't have a nice y value or nice y-intercept, I would say. So that's why I wanted to change this up. Okay, so X-intercept is, looks like we're going to make a guess at, that's a -1 and then y 0. Okay, so -1, 0. Y-intercept, which is a nice value, it crosses at -5 for y, but we do have to make a 0 for x, so 0, -5. So currently this one has 1 for each. Your domain is going to talk about all x values. So when you are having some problems trying to figure out the domain, I want you to say, okay, is there an arrow there? Is an arrow there? Is it ever going to get towards -1,000? Okay, or you want to get a bigger number? Go to -1 million. So ask yourself, is this graph ever go towards -1 million? If you said yes, then you can say, okay, that's a -infinity. Now, even this arrow to the bottom here, remember, it's eventually going to go out this way. So that's going to eventually reach -1,000, -1 million. So we call that, I'm sorry, not negative, positive, because we're talking about x this way. So that's going to be infinity. So if that's the case, we call it all real numbers, but also I want you to write both. I want you to write the interval notation as well, okay, from my -infinity to a +infinity. The range is exactly the same. It's also all reals, because it eventually will go up forever and down forever. And that's negative infinity down here and positive infinity up there. So we write the smaller number first, which is the negative number, okay? This one, we do not have a vertex, okay? So this is a brand new term for us. I know in Algebra 1, we know vertex already, but inflection point is some sort of a new item. Here's the inflection point, okay? Inflection point, let's circle that right now because it does not have a vertex. Inflection point is when it changes from, look at this, opening up, right? So concavity means opening up to opening downward, or vice versa. Sometimes it will start with opening down and then like this, right? So that's opening down and then changes opening up. So that's an inflection point. So we can label it as a -2, +3, okay? So again, inflection point is when it changes the concavity of the graph. It changes from opening up to down or vice versa. Now this one, we do not have a high or a low, okay? To have a high, we have to have this. To have a low, we have to have this. So this one does not have any. So we'll just write NA, okay? So we don't have a max or a min. End behavior, okay? So let's talk about end behavior. End behavior is as x approaches negative infinity. Well, if x approaches negative infinity, oops, this left side's going to go up. So the y is going to go up. As x is approaching positive infinity, what's happening to the y? Y is going to go lower and lower and lower. So that y is going to go down to negative infinity. So negative infinity. Increasing or decreasing? Okay, so is this where you can slide down, or is it where you have to do more work and climb up the mountain? Seems like this is where you can slide down, right? Whee! Your butt's right there. Okay, this is gonna go sliding down some more. So this is sliding down the entire time. Yeah. So this is decreasing because you're sliding down the entire time. And when you say entire time, it's gonna start from negative infinity all the way to positive infinity. Because you're sliding down the entire time. You have nothing left for climbing. So that's why climbing, increasing is none. It is definitely a function because it doesn't matter where I make my x, right? So let's make a few x's here to make a point. Only one y is happening. So it passes your vertical line test. Is it 1 to 1? Okay, well, let's make your y lines. That one y has 1x. This one y has 1x. This one y has 1x, and so on and so on. It also passes your horizontal line test. So it's also 1 to 1. Evaluate. Find x when y is -5. Okay, let's go find x. So this is where I go and draw a y line. Right there, okay? When I draw a line, y equals -5, x happens to be 0. So x equals 0. It happened to be the same point as our y-intercept. Let's move on to the next. Whoa, what happened? The next example. Now, this is another one that I changed slightly. The reason was that it was not clear to me on the graph where, on the original one anyway, if we had an open circle or a closed circle. So that's why I went and added the open and closed. Okay, so again, if you pick up an original packet, go ahead and sketch this out. So this one, X-Intercept, we have this dude over here. Let's count. So that's just -2. So this is -3 right here. So that's what? -3.75. So let's guess about -3. Okay, so this is -3.5. So -3.75. How about that? We're just gonna make your best educated guess there. So X-intercept is -3.75, and then y is always 0 for the intercept. Now, how about this point? It looks like it's intersecting the x-axis or touching the x-axis. Ah, it's an open circle. Open circle means it's non-inclusive. Okay, so it's not even there. Open circle means not inclusive. Okay, So we cannot include it in our answer because think of it as not even there. Y-intercept happens to be at the same open circle. So y-intercept, guys, is none. Okay. Your domain, this is going to be a little bit tricky, so I want you to pay attention because this is not a continuous graph. What I mean by that is not a, if I have to pick up my pencil, right, to graph both pieces, but we do know that this is an arrow, so that means it starts over here on a negative infinity for x. And as you can see, it takes a little break right here at -2, and that's a closed circle. So we give it a bracket. So that's the first piece right there. Okay, that first piece is right there. Then it continues. Well, here's the next x value, but that's an open circle. We use a parentheses to represent non-inclusive in mathematics. And because this goes on forever and ever and ever, because that means it's an arrow, so we know it ends over here at a positive infinity. So we go 0 to infinity. Now, I'm going to write it in here as my answer. What do we do with this in between? We use U for union. Think of it as as continuation, right? It's not just one side or the other. We want to continue both sides. Now, how would you write that old school? Well, let me get a different color pen so I can show you. What if I want to write it as an inequality? That's okay too. Inequality meaning that, okay, this is really x is in between inclusive, so that's why there's an equal sign, -2, and then non-inclusive at -infinity. Then over here, we write x, it's in between. Remember, both of them are parentheses, so we can't have an equal in our inequality. Well, x is going to be greater than 0 and then less than infinity. So you can write either one. I'm going to try to squeeze this in. Okay, here. You can pick either one, but start using the interval notation so you get more practice for it. Okay, let's go do the range. The range, again, we're going to do the same thing. I'm erasing what I had before so I can mark things up for the range. Now, if you need to hit pause so you can finish writing, feel free to do so. So the range is talking about all values of y. So let me get my blue pen back. So y, let's start with, okay, well, the lowest y, because again, this arrow, meaning that it's going to keep going down forever, so we will go all the way to -infinity. It goes up, 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 right? This arrow over here means we're going to go at positive infinity. So even though there's a break here, guys, in the middle, that's okay. Because even though this is not inclusive here at the origin, but there's a y value over here. So we don't have to worry about this break because, look, there's a y here, there's a y here, and a y here, and a y here. So that's why we can just say from -infinity to positive infinity, or we can say all real numbers. Do we have a vertex or an inflection point? In this case, we do not. So we're going to write none. Okay. Number of turning points. In this case, we don't have a turning point. So we'll write NA right there. Now, do we have any max or min? Technically, I don't want to go into this. Technically, in this class, we are only talking about the highest of the highest, okay? In mathematics, we call it absolute maximum and minimum. So for that reason, we're going to say that we do not have the highest of the highest max or the lowest of the lowest, which is called absolute min. So we're going to refer to that as no for right now. Next year or the year after, when you go to pre-calc or calculus, we'll get more into the smaller details of max and min. End behavior. Oh man, I marked too much right here. So end behavior is talking about as x goes towards infinity and -infinity, right? So here's -infinity for x somewhere over here. Y is going downward, so that's a -infinity. Similarly to over here, as x is going towards positive infinity, y is going up, so that's going to be positive infinity. Increasing or decreasing. Increasing because I have to hike this mountain here, right? Oh, that is so much work to hike up. But there's a little break, so we do have, when we write an increasing interval, we have to take into account of that break in between this x's right here. And then again, we pick up more hiking. At no point that we were decreasing, we couldn't slide down. So this one, decreasing, is Na. Increasing, we will start with negative infinity, and as you can see, here's a -2. And again, we're going to do a bracket to say that it includes that value. Then open 0 because it's an open circle. So we use parentheses all the way to, again, positive infinity. It looks pretty much like the domain, right? Yeah, increasing and decreasing interval, they are totally related to the domain. All right, negative infinity all the way to -2. Take a little break and then continue increasing. Oops, that's supposed to be parentheses. 0 to infinity. Is it a function? Okay, does it pass your vertical line test? I'm erasing again. I'm going to be erasing a lot. So every x I make, are you going to get 2 y's ever? No. So definitely a function. Okay. So if I make 1x, 1y, even here, this one has no y, but that's okay. This one has 1y, 1y. So it passes your vertical line test. So that's a function. Now the question is it a one-to-one function? If I make 1 y line, is it just 1x? The answer is no. I got 2 x's. Wah, 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 fail. So this is not a one-to-one function. This part of evaluating has 2 pieces, so let's focus on both. Find f of -2. Okay, so here is -2 for x, and your y value is right there. So that's 5. So let's see. 5, 6, 7. So that's 7. Okay. Then find f of 0. Okay, well here's 0 for x. Okay. But that's an open circle, y'all. So there's not an answer that we can write down. So we can write none, NA. Okay, it doesn't exist. I'll take any one of those. So same thing, let's find the x-intercept. We have 1 at 0 and 1 at 5. So we write 0, 0 and 5, 0. Y-intercept happens to be at the origin, so we can copy that 0, 0 back down. Your domain by now, hopefully you guys know that this is all real numbers, or interval notation goes from -infinity to positive infinity. Range, this is a little bit trickier, so let's see where the highest y value is. So that's 6, and 6 is right there, so it looks like 6.25. Okay, so this high value is 6.25. So we want to start, remember, we want to write it as an interval, so that means we have to figure out what the smaller value than that is, and it goes down forever. So we want to do -infinity all the way to 6.25, and then a bracket because it includes 6.25. Now we could also write inequality. We can say y is less than or equal to, 6.25. I'm kind of running out of space. I'm going to try to squeeze that in, 6.25, just like that. We do have one vertex, which is at the very top, okay? And our vertex happens to be the same as our highest range value. So we'll circle the vertex. The vertex is, what's the x value there? So we know y is 6.25. What is x? X is 2.5. So 2.5, 6.25. Okay. Number of turning points, because it is continuous, so we can say there's 1 turning point due to the fact that we do have a vertex. So we got 1. We do have a maximum because we have a vertex. Usually you have a vertex indicate you have a maximum in. So a vertex, we can say, okay, so maximum is 6.25 at x equals 2.5, or we will accept 2.5, 6.25. So if you want to copy your vertex back down, that's okay too. And behavior, as x is going to the left, which is -infinity, y looks like it's going downwards, that's -infinity. As x is going to the right, which is positive infinity, y is also going towards -infinity. So as you can see, both sides are going downward. Increasing interval, increasing interval meaning that you're making this hike. Okay, so you are exerting more energy here because you're hiking up. So you are starting from -infinity And normally increase and decrease, you are stopping at the vertex or at the maximum, which the x value is 2.5. Decreasing is when you can slide down, whee, right? Hands up, how about that? Because you're sliding down. So that's going to be starting where the increasing ended and then go all the way to infinity. Is it a function? Sure it is, because you can make any vertical line test you want. Any x mark that you make, you will only have one y. Is it a one-to-one? I don't think so. Look, I can make a bunch of horizontal line tests. That means every y that I had made so far have gotten 2 x's. So this is not a one-to-one. Evaluate. Find x when y is when y is 6. So I gotta erase some. So what is x when y is 6? I made too much marks already. So so make a line at y equals to 6. Just like that. All right, first x is right here, which is at 2. Okay. Then the next x is right here, so that's at 3. So you got 2 x's, x equals 2, and then you can do a comma 3. So we have one more after this. The last one is very different. So hopefully by now I can go a little bit quicker. X-Intercept. Let's see, you got 1 right there, 2 right there, and 3. So the first one is -1, 0. Then we have at the origin, which is 0, 0. Then we have one more, and it's 4, 0. We have a y-intercept, 1 y-intercept right at the origin. So that's going to be 0, 0. Your domain is going to be all real because it's going to go from -infinity to +infinity. So all reals or -infinity to +infinity. Your range is going to start right here in the bottom. So it's -7.25, excuse me. And it goes upward forever. So that's going to go all the way to +infinity. Or you can write y is greater than or equal to 7.25. Okay, either one is going to be okay. Vertex, ooh, man, we're going to have a few of these, so let's look for them. We have one right there, one right at the origin, and one over here. So if I were to take the first guess, okay, the first vertex, let's see what that y value is. Okay. How about we say that first vertex is -0.75, comma, for the sake of simplicity, comma, -0.25, okay? So so 0.75, 0.75, comma, -0.25. That's the very first vertex. Let's circle the vertex. Then the second vertex is at the origin, so that's 0, 0. Then the third vertex, again, for simplicity's sake, we're going to say that 3, comma, negative, so 3, comma, -7.25. Okay, so number of turning points, because we got 3 vertices, we have 3 turning points. Okay? We do have some mins, okay, and some maxes here. So we have one peak, which is at the origin. So that's your max. Max is going to be 0 at x equals 0, or we can write 0, 0. We also have a couple of mins, right? We have the first min, which is this guy right here, and we said that was the vertex. So min is -0.25 at x equals -0.75, or we can write that just like the vertex, -0.75, comma, -0.25. Now the second min is right here in the bottom, so we can write, and what's the second min? That's the y value is -7.25. So min is -7.25 at x equals 3, or we will take it just like the vertex, 3, comma, -7.25. I'm trying to squeeze in that spot. So for this one, you can write your min as a 2-order pair, just like the the vertex. End behavior. What's happening to y as x is going to the left? Y goes upward. Same thing with as x is going to the right, y is also going upwards. So both right and left end behavior are positive, going up and up. Increasing interval. Okay, so now this is where we have to look at the vertices or your max and mins and see what's happening. So here's the first vertex. This is over here. You are sliding down. So that's okay, so that's decreasing. So that's from negative infinity, and we talked about that x being a negative 0.75. So that's your first decreasing. So negative infinity, negative 0.75. Then let's check out the next, let me get a different color pen. Next vertex, which is this guy right here. That's not a big hike, but it's still a going upward trend. Can you see that right there? So that tiny piece is an increasing, and that increasing piece is negative 0.75, and it ends at 0. Next, we are going to find this right here. This again is going downward, so you can see that is a sliding, so that's decreasing. So we will go from x value of 0 all the way to, this was 3. So we can say 0 all the way to 3 is a decreasing. Then we're hiking again up this way. Whew, this is much steeper hike, right, than the other interval. So union that with from 3 all the way to the rest. So it looks like it's increasing indefinitely from there. Is it a function? Of course it's a function, right? Because would you agree that whatever x I pick, I only have one y, so it is a function. Is this a one-to-one function? Definitely not, because if you draw your y line, you have two x's, so that's not okay. Evaluate. Find x when y is 0. All right, let's see. Let's make my y equals to 0 line. All right, here we go. That's one x-intercept already, 2 and 3. So 1, 2, and 3. So when y is 0, x is at negative 1, comma, 0, comma, 4. What? That's the same as the x-intercept? Yes, it is. And see, they are totally related at different places. All right, guys, we are on the last example. It's a sketch a graph with all the information to the right. Can you do me two favors? One, fix that to negative 18 and then circle this right here. We do not want any inflection for this particular sketch. Okay, let's start with the x-intercepts. We have 3, it's negative 3, 2, 4, 5, and positive 7. So check. We have one y-intercept. I did ask you to change it to negative 18, so we don't have enough tick marks down here. So what we are going to do is changing the scaling. Yep, you can always do that. We are now going to scale every tick mark as 2 units. So 2, 4, 6, 8, 10, negative 12, negative 14, negative 16, negative 18. So negative 18 is right there. So those are my dots. Okay, check that one. Now I do want you the next, so after plotting your x-intercept, y-intercept, I want you to go just all the way to the endpoints. As x is approaching negative infinity, y is approaching positive infinity. So that means it's left and upward and arrow. Same thing with the right side. As x is approaching positive infinity, y is going downward. So I'm going to connect those just like that. So check with that. Then go jump to an increasing interval. And now this increasing interval is only between 1 and 6. So what I'm going to do is I'm going to get a different color pen and mark 1. It's right here. So I have an idea of 6 is right there. So if it's only increasing from 1 to 6, I'm going to, how about this? Make a dot right there because that's where 1 is and 6 is. And I'm going to go just like that. Okay, so that's increasing. So that's right there. And it, okay, so next we are now doing decreasing interval, which I'm going to use a different pen from negative infinity to 1. Okay, so I've already started a little bit over here. I'm just going to continue. So negative infinity all the way to 1 and make sure I cross over that y-intercept at negative 18. That one's done. Then 6 to infinity, decrease. Well, I already have the blue piece, so I'm just going to connect that and make it nice and smooth. So as you can see, I have a nice little function. I'm going to use black to kind of trace it all together. That's one X-intercept I just passed, a Y-intercept I just passed, and then going up, because this is now increasing past the second intercept there. And then now it's a decreasing interval passing the third intercept, and then these are my end behavior. Voila. Now, but before we wrap it up, let's check the rest. Is it a function? Yes, it is. It's not a one-to-one. Yep, that's okay. We have two turning points. One is a max up here, and one's a valley, which is the minimum down there. Then we have a domain of all reals and a range of also all reals. We have a max and min, so go ahead and cross that out for now. We have a high up here somewhere. So how about this? Instead of NA, why don't we write it doesn't matter, okay? Any, how about that? Any, so that way it's just an approximation, okay?